Welcome back to another video. We will be solving O-Level Mathematics Paper 2 Variant 1 for May-June 2016. So let's start. Question number 1 is a shopkeeper buys some plates from a manufacturer for $12 each. The manufacturer makes a profit of 60%. Calculate the cost of manufacturing each plate. So let's assume that the manufacturing cost, manufacturing cost equals to X dollars. And then the manufacturer makes a profit of 60%. So the profit will be 60% of X, which is 60 over 100 times X, or 0.60X. So the sale price, or the price at which the shopkeeper buys the plate from the manufacturer, is $12. That means the manufacturer sold each plate for $12. So the selling price will be the cost price plus the profit. So this will be X, which is the cost price, plus 0.60X, which is the profit, should equal the selling price of the manufacturer, or the price at which the shopkeeper bought it from the manufacturer, which is $12. So this will be 1.60X equals to 12, and X will be 12 divided by 1.60. So 12 divided by 1.60 will be 7.5. So this will be $7.5. So the manufacturing cost of each plate is 7.5. Part B is the shopkeeper sells each plate for $17.40. Calculate the percentage profit made by the shopkeeper. So the cost price for the shopkeeper is $12, at which he bought it from the manufacturer, and the sale price is $17.40. So the profit will equal the sale price, 7.40, minus the cost price, which is 12. So 7.40 minus 12 will be $5.4. So $5.4 is the profit, but we need to calculate the percentage profit. So percentage profit will be the profit, which is 5.4, divided by the cost price, which is 12, times 100. So this is 5.4 divided by 12 into 100. So this is 45%. So the percentage profit is 45%. Part C is, in a sale, each plate is reduced from $17.40 to $11.31. Calculate the percentage discount given. So first we need to calculate the discount in dollar amount. So discount will be 17.40, which was the original price, and minus 11.31, which is the price during this, after this discount. So the discount is 7.40 minus 11.31, which is 6.09. So the discount here is $6.09. So percentage discount will be equal the discount in dollar amount, which is 6.09, divided by the original price before the discount, which is 17.40, and then multiplied by 100. So 6.09 divided by 17.40 multiplied by 100. So this is 35%. So the percentage discount here is 35%. Part D is the shopkeeper buys 100 plates at $12 each. He sells 60 plates at $17.40 each and X plates at $11.31 each. The shopkeeper makes a profit of at least 10%. Find the least possible value of X. So you're given that the percentage profit is at least 10%. That means it is greater than equal to 10%. So if we can find the calculate percentage profit, we can substitute this in this inequality to find the least possible value of x. So first, to calculate the percentage profit, we need to find the profit. So let's start with the cost price first. So cost price is how much he buys 100 plates at $12 each. So cost price, total cost price, you can say, is 12 into 100, which is $1,200, right? And then total sale price at which he sold the plates. He sold 60 plates for $17.40. So 16 into 17.40 plus he sold X plates at 11.31. So X into 11.31. So 60 into 17.40 is 1044 plus 11.31 X. So this is his total sale price. And then we can calculate the profit. So profit will be the sale price, which is 1044 plus 11.31x minus the cost price, which is 1200. So this will be 1044 minus 1200 minus 156. So this is 11.31x minus 156. This is the profit. But we need to calculate the percentage profit. So percentage profit will be percentage profit will equal the profit, which is 11.31x minus 156 divided by the cost price was 1200 multiplied by 100. So this is our percentage profit. And now we can substitute it here. So let me continue here. So 11.31x minus 156 over, so I can cancel these zeros out here. So this could be over 12 should be greater than, so this is your percentage profit. It should be greater than equal to 10%. So greater than equal to 10. So now let's find the value of x. So if I take this 12 to the other side, I will get 11.31x minus 156 should be greater than equal to 120. And then if I take this 156 to the other side, I will get 11.31x greater than equal to 120 plus 156, which is 276. So x should be greater than equal to 276 divided by 11.31. So this is 24.4. So your value of x should be greater than equal to 24.4 in order to get a percentage profit of 10%. So since x is the number of plates sold, you cannot have like a decimal value, and you cannot go below 24.4. So 24 is not a correct answer because your percentage profit will drop below 10%. So the least possible value of x will be 25. So your answer here is 25. So if the shopkeeper sold 25 plates at 11.31 and 60 plates at 17.40, we can guarantee that he makes a profit of at least 10%. So you have to make sure you satisfy this equality. So the next integer value greater than 24.4 is 25. So that's why you will have to have an integer value because x is the number of plates sold. So question number 2 is solve the equations p minus 1 over 7 minus p equals to 5. So if I take the 7 minus p to the other side, I will get p minus 1 equals to 5 times 7 minus p. So p minus 1 equals 35 minus 5p. So I bring this 5p to this side, I will get p plus 5p, p plus 5p. And then if I take this 1 to the other side, I will get 35 plus 1. So this will be 6p equals to 36. So p will be equals to 6. So your answer here will be 6. Part B is simplify this expression. So first let's simplify the expression inside the bracket before we bring this power inside. So let me write it again, 9ab power 6 over a cube b square and then whole power 1 over 2. So this is a cube and this is a power 1, so I can cancel this and this will be left as a square. This is b power 6, so and this is b square, so I can cancel this b square and this will be 6 minus 2, so powers will be subtracted and you will get a 4 here. So then I will be left with 9b power 4 in the numerator, and in the denominator I will have a square. And then you have whole power 1 by 2, which is basically the square root. So if I bring this power in, square root of 9 is 3. B power 4 will be multiplied by this power 1 by 2. So 2 ones are 2, 2 twos are 4. So b square is left. And then this 2 square, a square, the power 2 will be cancelled with this denominator 2 once I bring this in and multiply the two powers. So I will be left with a here. So your final answer will be 3b square over a. Part C is simplify this. So in the numerator, I can take q square common. I will be left with 1 minus q. And then in the denominator, I can take 3 common. So I'll be left with 1 minus q as well. So 1 minus q and 1 minus q will cancel out. And I'll be left with q square over 3. So your answer here will be q square over 3. Part D, part 1 is factorize this expression. So if I multiply the coefficient of t square, which is 4, and then the constant, which does not have any t with it. So this will be minus 9 times 4, which is minus 36. So since it's a negative sign, I have to look for factors of 36, which if I subtract, I should get this middle number, 35. So it's pretty simple, 36 and 1. So if I multiply them, I will get 36. If I subtract 1 from 36, I get 35. So this I can rewrite this equation as 4t square plus 36t minus 1t, which is minus t, minus 9. So 36t minus t gives me 35t. So this is good. And then I can take 4t common here. So 4t, I will get t plus 9. And then if I take minus 1 common here, I will get t, and this negative sign will be converted into positive since I took the negative outside. So this will be t plus 9 into 4t minus 1. 4t minus 1. Part 3 is hence solve this equation. So this is the same expression that we factorized in the previous part. So I can rewrite this equation as t plus 9 into 4t minus 1 equals to 0. So that means t plus 9 equals to 0, or 4t minus 1 equals to 0. So t equals to minus 9 or t equals to 1 over 4. So t equals to minus 9 or 1 over 4. So question number 3 is the table below is for y equals to x square plus x minus 3. Using a scale of 2 centimeter to 1 unit for x-axis and 1 centimeter for 1 unit for y-axis, plot the points from the table and join them with a smooth curve. So let's first draw the axis here. So this point here will be 0. And then for the x-axis, you're taking 2 centimeter for 1 unit from minus 3 till 2. So 2 centimeters for 1 unit. So this will be 1. This value here will be 2. And then this will be minus 1, minus 2, and then minus 3. And similarly for y-axis, we have 1 centimeter for 1 unit from minus 4 to 4. So 1, 2, 3, 4. And then minus 1, minus 2, minus 3, and minus 4. So this is how you will draw the axis. So now let's plot the points. So the first point is -3 and 3. -3 and 3 will be this point. -2 and -1 will be this point here. -1 and -3. -1 and -3 will be this. 0 and -3 will be this one. 1 and -1. And then 2 and 3. So now we can join them to draw a smooth curve. So since this, after this point, it kind of goes back up, so your like minimum point will be between the middle of these two. So let's draw this curve now. Let me draw the last part again. All right, so this will be your curve for these points. The next part is use your graph to estimate the solution for equation x squared plus x minus 3 equal to 0. So this is the same equation as this one, y equals to x squared plus x minus 3. So y equals to x squared plus x minus 3. So your y is this value, y equals to 0. So you have to basically see where the graph for this uh, intersects the line y equals to 0, which is the x-axis. So first point will be this one. So let me mark this. And the second point is this one here. So here the x value is minus 2.5 is this one. So this is minus 2.4 minus 2.3. So your x value here is minus 2.3 and the other value is 1.3, where the graph intersects the x-axis. The next part is use your graph to estimate the solution for this equation x squared plus x minus 5 equals to 0. So if you compare this with this, the only difference is here it's minus 5, here it's minus 3. So x squared plus x minus 5 equals to 0. I can rewrite this in this form. So this will become x squared plus x minus 3, the same as this one. And then another minus 2 equals to 0. And then x squared plus x minus 3. If I take this 2 to the other side, it becomes positive 2. So now you have this same equation. On this, in the previous part, you had y equals to 0. Here you have y equals to 2. So you basically have to see where this graph intersects the line y equals to 2, similar to how you checked for intersection at y equals to 0 in the previous part. So y equals to 2 is this line. If you want, you can draw a line here as well, but since we already have the grid, I can quickly check. This is the point where it intersects the this curve. So this point here is minus, so this point here is minus 2.8. So your first value will be minus 2.8, and the other value where it intersects the line y equals to 2 is this. So this is almost positive 1.8. So your value here will be 1.8. So you basically checked. So this was your second point where this curve intersects y equals to 2. Part C is by drawing a tangent, estimate the gradient of the curve at 1 and minus 1. So 1 and minus 1 is this point here. So what we will do is we'll draw a straight line that touches the graph at this point where x value is 1 and y value is negative 1. So let me align my ruler such that the graph just touches this curve here. So this looks about right. So now I can basically draw a straight line here. So yeah, so let me use the ruler here to draw a straight line. So now I can take any 2 points on this line to calculate the gradient of the curve at this point. So let's take this point here. So the x value here is 2 and the y value is 1, 1.2, 1.4 and 1.6. And let's take the value here at the point where this straight line intersects the x-axis. So your x value will be 0 here. So in fact, let me write it down here. So basically, this point here will be 0. Oh, no, sorry. Your y value will be 0. So your y value is 0 and your x value here is 1 point, almost 1.4. So now you have 2 points, 2 and 1.6. So 2 and 1.6, and the other one is 1.4 and 0. So now we can easily calculate the gradient. Gradient will be y2 minus y1, so 1.6 minus 0 over 2 minus 1.4. So this will be 1.6 divided by 0.6. So 1.6 divided by 0.6 is 2.67. So your gradient is 2.67 up to 3 significant figures. So 2.67. Part D is the equation x squared minus x minus 1 equals to 0 can be solved by drawing a straight line on the graph of this curve y equals to x squared plus x minus 3 that we have drawn in the first part. Part 1 is find the equation of this straight line. So you have your curve which has this equation y equals to x squared plus x minus 3, and then you have a straight line. So your equation for straight line is y equals to mx plus c, and then your solution is this equation, which is x squared minus x minus 1 equals to 0. So that means if I solve this equation simultaneously with this equation, I will end up with this equation. So that means if I somehow eliminate the variable y, I will end up with this equation. So this is pretty similar to other questions in which you're usually given this equation of the straight line and you're given the solution as x squared plus ax plus b equals to 0, and then you're asked to find the values of these constants a and b. So you can look at the October-November 2019 paper 2 variant 2. So the question number 4, last part in that paper, is pretty similar to this one, but in that one you have been asked to find the values of these constants and you're given the equation for the straight line. So in this you're given the solution, but you have to find the equation of the straight line. So what we can do is, again, we can solve them simultaneously and then compare it with the final equation here. So from this equation of the curve, I can substitute this value of y in this equation of straight line. So if I substitute this y value here, I will get x squared plus x minus 3 equals to mx plus c. And now we have to convert this equation into this form. So I'll take everything to one side. So I will have x squared plus x minus mx minus 3 and then minus c equals to 0. So this is x squared plus 1 minus m times x minus 3 minus c equals to 0. Now I can compare the coefficients directly. So x squared has coefficient 1 and 1 here. X has a coefficient minus 1 here, and here the coefficient of x is 1 minus m. So let's compare the two. So 1 minus m should equal the coefficient here, which is minus 1. So if I calculate m, if I take this m to the other side and bring this 1 here, I will get m equals to 2. And then similarly, I can compare the constant value with which has no x variable with it. So here it's -1, here it's -3 minus c. So -3 minus c should equal this -1 in this equation. So this will give me minus c equals to plus 3 minus 1 will be 3 minus 1 is 2, and then c will be -2. So now you have m and c values. So your equation of this straight line, which was y equals to mx plus c, will equal y equals to m is 2x, oh sorry, m is 2. So this will become 2x plus c is -2. So this will become -2. So equation of the straight line is y equals to 2x minus 2. So if you solve these two equations simultaneously, you will end up with this equation. You eliminate the variable y. So since it was given in the question that the straight line and the graph will result, if you draw a straight line and the compare it with the, or not compare it, in fact, look at the intersection of the straight line with this curve, you will get the solution for this equation. So that's how we use the equations to substitute the value of y in one of these equations and bring it to the bring it equal to the solution equation that you are given here. So the next part is draw the straight line and solve x square minus x minus 1 equals to 0. So that means you have to draw the straight line, and wherever the straight line intersects the curve of this equation, which we have already drawn, that will be the solution of this equation. So let's take a couple of points. So when x equals to 0, your y value will be -2. You substitute 0 here, you'll get -2. And then let's take x equals to 3. So 3 2s are 6, 6 minus 2 is 4. So you have 2 points, 0 and -2, 3 and 4. So let's plot this. 0 and -2 will be this one. And the other point was 3 and 4. So in fact, 3 and 4 is outside the grid. So let's take another point here. Let's take x equals to 2. So 2 2s are 4, 4 minus 2 is 2. So at x equals to 2, y value is 2. So 2 and 2 will be this point. So now I can join these 2 points to get the straight line. So so this will be your straight line for the equation y equals to 2x minus 2. And then since you have to find the solution, so that means you have to find the points of intersection. So your first point of intersection is this one, and your second point of intersection is this one here. So this is almost negative. So your x value here is negative 0.6, and your x value here is almost positive 1.6. So your solution here will be negative 0.6 and positive 1.6. So question number 4 is A and B, BL, C and CMA are straight lines. So these are all straight lines. This line is parallel to this one, and this line is parallel to this one. Prove that triangle ANM is similar to triangle NBL. ANM is this one, and NBL is this one. Give a reason for each statement you make. So straight away we can see that this angle will be equal to this angle because these two are parallel lines. NM and BL are parallel, and NB is the line that is passing through these two parallel lines. So these are two corresponding angles. So ANM will be equal to angle NBL because they are corresponding angles. Next, if you look at this angle AMN, so this angle here, this is equals to this angle MNL, because if I extend this line like this, and if I extend this line like this, so these are alternate angles. So you have two parallel lines LN and CM, and you have this line MN which is passing through these two parallel lines, and these two are alternate angles. And similarly, MN and BL are parallel, and NL is now passing through these two parallel lines. So this angle MNL will also be equal to this angle BLN, because these are also alternate angles. So you can say angle AMN, this angle, equals to angle MNL, which in turn is equals to angle NLB, because they are all alternate angles. And then you have this angle, this will be equal to this angle, because this is the only angle remaining in the triangle. We have shown that the other two are equal. So angle NAM, NAM equals to angle BNL. And the reason for this is because it is the third angle in the triangle, because the sum of three angles should be 180. So if these two and these two are equals, that will mean that this angle red here will equal to this angle red. Part B is AN ratio NB is 2 ratio 3. So AN, if this is 2, NB is 3, and then this full length will be 5. Find NM ratio BC. So NM ratio BC is what you have to calculate. So if you look at this triangle A and M, it is also similar to triangle ABC, because this angle is also equal to this green angle. So this will also be the same, because if you look at these two parallel lines, this is a line which is parallel to this line. This line is passing through these two parallel lines. So this angle will equal to this angle, because these are two corresponding angles. So that means, so let me draw these separately as well. So if you have this small triangle A N M, and then you have this big triangle ABC. So your big triangle is this one, ABC. So you have these angles that are equal, and then you have these angles that are equal, and then you have these angles, red ones, which are equal. So A and M and ABC are also similar triangles. So this length is 2 AN, and this full length is 5. And then you have to find the ratio of NM ratio BC. So this ratio will also be the same as the ratio of these two corresponding sides, because these are similar triangles. So NM ratio BC will be equal to this side AN ratio AB. So this will be AN ratio AB, and which is AN is 2 and AB is the full length, which is 5 here. So AN is 2 and AB is 5. So your answer here will be 2 ratio 5. Part B is area of ANM, area of NBL. Area of ANM and NBL. So this will be pretty straightforward. Again, you have the ratio of corresponding sides. AN is 2, NB is 3. And since these are similar triangles, the square of their ratio of their sides will be the ratio of their areas. So this will be AN side squared ratio NB side squared. So AN is 2 square, the square will be 2 square, and NB is 3 and the square as it is. So this will be 2 ratio 9. So this ratio of areas will be 2 ratio 9. Part 3 is area of ANM and NMCL. So again, ANM is this one, and then NMCL is this parallelogram, this one here. So if I look at this big triangle, it includes this triangle ANM, this triangle NBL, and this parallelogram. So I have to basically find the ratio of this area of this small triangle with the area of this parallelogram. So what I can do is we have already shown that these two triangles, this small one and this big one, are similar. So I can take the ratio of their areas, and then from the large one I can subtract this small one and this NBL to get the remaining, which is the parallelogram. So area of ANM will be again 2 square. So area of ANM will be 2 square ratio area of NMCL. So that's, I'm calculating it by getting the area of the large triangle, which has side 5. AB is 5. So this will be 5 square. So 5 square, and then minus the area of this small triangle, which has side 2. So this will be 2 square, minus the area of triangle NBL, which has a side 3. So this will be 3 squared. So this will be eventually 5 squared minus ANM, which is the small triangle, 2 square, minus the area of this triangle NBL, which has a side 3. So this will be 3 squared. So this will be 4 ratio 25 minus 4 minus 9. So this will be 4 ratio 25 minus 4 minus 9. So remaining area is 12, which is the area of this parallelogram NMCL. And then I can simplify it further. I can divide by 4 on both sides. So I will get 1 ratio 3 in the simplest form. So this is how you will solve this. Question number 5. AB is vertical and CB is horizontal. So AB is vertical, CB is horizontal. That means this is a 90-degree angle here. AB is 31, CB is 115. Calculate the angle of depression of C from A. So angle of depression will be, if I draw a straight line here, so this is the angle of depression that we need to calculate. So if I can find this angle, we know that this full angle is 90 degrees. So this full angle here is 90 degrees. If I find angle CAB, I can subtract it from 90 to get the angle of depression. So to find the angle CAB, I have two sides of this right angle triangle. This will become the perpendicular. If I'm looking from this angle CAB, this will be the base. So I can use tan. Tan of angle CAB will be equal to this side BC over this side AB. So tan of CAB will be, BC is 115 and AB is 31. So angle CAB will be 115 divided by 31, and then tan inverse of this. So this is 74.9 up to 1 decimal place. So now angle of depression. So CAB, this angle CAB, this one here, plus this angle of depression plus angle of depression should equal this full angle, which is 90 degrees. So angle of depression will be 90 minus this angle CAB, which is 74.9. So 90 minus 74.9 will be 15.1. So this angle here is 15.1 degrees, which is the angle of depression of C from A. So this is 15.1 degree. Part B is J and K are two positions at C. The base of lighthouse is at L. J is due east and K is due south of L. So that means this angle is 90 degree if this is east and this is south. Then this is 354, this is 1100 meters. Calculate the angle LJK. LJK is this angle that we need to calculate. So this is a right angle triangle. So I can use sine of LJK will be this perpendicular height, which will be LK divided by this hypotenuse, which is KJ. So sine of LJK will equal LK is 354 divided by KJ is 1100. So LJK angle will be 354 divided by 1100, and then sine inverse of this 18.8 degrees up to one decimal place. So 18.8. Hence find the bearing of K from J. So bearing of K from J, so if I draw the north-south line here, so this is the north, and the bearing of K from J will be this angle here. And since J is due east of L, that means L is due west. So this is west of J. So that means this full angle up till this point. So this angle, in fact, let me draw this again. So this full angle here is 270 degrees because this point L is west of J. So if I know this angle is 18.8 degrees. So if I subtract 18.8 from 270, I will get this blue angle, which is the bearing of K from J. So bearing of K from J will be, so bearing of K from J will be 270 minus this angle 18.8. So 270 minus 18.8 will be 251.2 degrees. So this will be 251.2 degrees. So this blue angle here is 251.2 and this is 18.8, and this full angle, when you sum these two blue angles, you get 270. Question number 6 is you are given two matrices A and B. First part is evaluate 2A minus B. So to calculate this, 2A will become 2 into 4 minus 1, 1, 3, and then minus B will be 2, 0, 7, minus 5. So if I take this 2 inside, I will get 8, minus 2, 2, and 6, and then minus 2, 7, 0, minus 5. 8 minus 2 is 6, minus 2 minus 0 will be minus 2, 2 minus 7 will be minus 5, 6 minus and minus will become plus, 6 plus 5 will be 11. So this is 2A minus B. Part B is find A inverse. So A inverse will be A times A, which is 4 minus 1, 1 and 3 times A again. So this is a 2 by 2 matrix. This is also a 2 by 2 matrix. So if you cancel the column with the rows of the second, you will get 2 by 2. So your answer will also be a 2 by 2 matrix. So let's calculate that. So first row multiplied by first column, I will get 4 into 4 plus 1 into minus 1. And then first row multiplied by second column. So I will get 4 into minus 1 plus minus 1 into 3, minus 1 into 3. And then second row, first column, this will be 1 into 4 plus 3 into 1. Second row and second column, I will get 1 into minus 1 plus 3 into minus 3. Sorry, 3 into 3. And then if I simplify this, this will be 16 minus 1, which is 15. This is minus 4, and then minus 3 will be minus 7. This is 4 plus 3, which is 7. And this is minus 1 plus 9. So minus 1 plus 9 will be plus 8. So this will be your final answer here. 15 minus 7, 7 and 8. Part B is find B inverse. So B is 207 minus 5. So B is 207 minus 5. So to find the inverse, first we need to find the determinant. So determinant of B will be 2 times minus 5 minus 7 times 0. So this will be minus 10. And then your B inverse will be 1 over determinant, which is 1 over minus 10 into the adjugate of B. So adjugate of B is you swap the places of these two. So this will become minus 5 and 2. And then you change the signs of these two values. So 0 will remain 0. 7 will become minus 7. So this is minus 5, 0, minus 7 and 2. So you can write this as minus 1 over 10 multiplied by minus 5, 0, minus 7 and 2. So this will be your B inverse. So the next part is A plus Z equals A, find Z. So before I substitute values, I can take this A to the other side. So Z is basically A minus A. So this will be a zero matrix. So let me substitute the values to show as well. So A is 4 minus 1, 1, 3. So 4 minus 1, 1, 3 minus 4 minus 1, 1, 3. So 4 minus 4 is 0, minus 1 plus 1 will become 0, 1 minus 1 is 0, 3 minus 3 is 0. So this will be simply 0, 0, 0 and 0. Part E is M plus 2I equals to B, where I is the 2 by 2 identity matrix. Find M. So identity matrix is 1, 0, 0, 1. So let's substitute the values. So M equals to, M plus 2 times the identity matrix. So identity matrix is this 1, 0, 0, 1 equals to the matrix B. So B was 207 minus 5. So 207 minus 5. Now you have to solve this to get the value of M. So if I multiply this 2 inside, I will get M plus 2002 equals to 207 minus 5. And then I take it to the other side. So M equals to this matrix 207 minus 5. Let me write this again. So this is 207 minus 5. And then minus this matrix that you took to the other side of the equation. So this will be 2002. So once I subtract 2 minus 2 is 0, 0 minus 0 is 0, and then 7 minus 0 is 7, minus 5 minus 2 will be minus 7. So your final answer will be 0, 0, 7 and minus 7. So question number 7 is AC is the diameter of the circle, center O and radius 5 centimeter, ACB is 64 degree. Calculate the length of the minor arc BC. So you're looking to find the length of this arc. And if you look, if we can find this angle, this becomes a sector of a circle, of a bigger circle, whose radius will be the diameter of this smaller circle that that is drawn here. So since AC is the diameter, this angle will be 90° because we know that angle subtended by the diameter on the circumference of the circle is 90°, or it's also called angle in semicircle, which is 90°. So now angle BAO plus 90 plus 64 should equal 180°. So this will give us angle BAO equals to 180 minus 64 minus 90. So this is 26 degrees. So this angle here is 26 degrees. Now if we take this as the radius of this sector BAC, then this arc length will be, so arc BC will be 26 degree over 360 into 2 pi r, 2 pi into, now this r is 10, which is the diameter of this circle here. So you'll multiply it by 10. So 26 divided by 360 multiplied by 2 pi into 10. So this is 4.54 up till three significant figures. So 4.54 centimeter will be your this arc length BC. Part B is a baking tray is an open cylinder of radius 15.5 centimeter with a rim. The outer edge of the rim is a circle of radius 16.5 centimeter. So this is the rim on the top, and this is the top view. Your inner radius is 15.5 and outer radius is 16.5. So the first part is calculate the area of the top surface of the rim. So this is basically the top surface of the rim is this shaded area because this part is hollow. So if you look at this top part, there's nothing on the top here, as this is like the opening of this baking tray. So the only area of the top rim is this shaded area here. So you have to find this shaded area. So we have two circles. The bigger circle has radius 16.5. The smaller circle has radius 15.5. So what we can do is we can find the area of the large circle and then subtract the area of this inner smaller circle. This will give you this area which is shaded. So this area will be, let's call it pi capital R square, which is the radius of the larger circle, minus pi smaller r square, which is where small r is the a radius of the inner smaller circle. So this will be, I can take pi common, I will get r square minus r square. So this will be pi into, the larger radius is 16.5 and smaller is 15.5. So this will be 16.5 square minus 15.5 square. So 16.5 square minus 15.5 square is 32, and then I'll multiply it by pi. So this is 100.530. So up till three significant figures, this will be 101. So this will be 101 centimeter square, which is the area of the top surface of the rim. Part 2 is 44 identical circular holes are cut out of the bottom of the baking tray. The area of the bottom that remains is 650 centimeter square. Calculate the radius of each circular hole. So now you're given the area that remains after you cut out these holes. So if you look at the tray again, so you're basically cutting the holes at the bottom of the tray here. So something like this. And you're given that the area that remains after you cut these out is 650. So what you can do is you can calculate the total area of the bottom. So the total area of the bottom will be this circle, inner circle area with radius 15.5. And then you can subtract the area of these holes, and that will result in the remaining area, which is 650. So let's first calculate the bottom area. Bottom area of the tray, which is pi r square, small r that we took in the previous part is 15.5. So this will be pi into 15.5 square, which is 15.5 square into pi. So this is 754.768. 754.768 centimeter square. And then let's calculate the area of the circular holes that are cut out. Area of circular holes will be pi. Let's call the radius as y. So let me say let radius that we need to calculate here, radius of each circular hole. Radius of circular hole equals to y. So area of circular holes will be pi y square. So this will be the area of one circular hole, and then you cut 44 of these. So you multiply it by 44. So this will be 44 pi y square. And then the remaining area will be equal to this area, which is 754.768, which is the total area of the bottom of the tray minus the area which is cut out, which are these holes. So this will be 44 pi y square. And you're given that remaining area is 650. So this will be 650 equals to 754.768 minus 44 pi y square. So now we have to find the value of y from this equation, which is the radius of the circular hole. So this is 650 minus, I'll take this 754 to the other side. So 754.768. So this will be minus 104.768. So minus 104.768 equals to minus 44 pi y square. So minus and minus will cancel out. So I will divide this by minus 44 into pi. So I took this minus 44 pi to the other side of the equation. So it will be divided on the other side. So this will be y square. Minus and minus cancel out. So I get y square equals to this value 0.75792. And let me continue here. So y will be the square root of this. So let me take the square root of this. So this will be 0.871 centimeter up till three significant figures. So the radius of each circular hole that you cut out is 0.871 centimeters. Part 3 is to make a pizza. The baking tray is completely filled with dough to a depth of d millimeters. The open cylinder holds 500 centimeter cube of dough. Calculate the depth of the dough d millimeter, giving your answer correct to the nearest millimeter. So we know that the cylinder can hold 500 centimeter cube of dough. So your volume of tray is equals to, so since it is a cylinder, it will be pi r square h, where r is this radius 15.5 and h is the height, which is d. So volume of tray we know is 500, then pi into 15.5 square into h d millimeters. So we have to convert this millimeter into centimeters. So d millimeter in centimeters will be d over 10. So if you divide by 10, you can convert millimeters into centimeters. So since everything else, your volume is in centimeter cube, your radius is in centimeter, so your height should be in centimeter as well. So you divide your depth d millimeters by 10 to convert it into centimeters. And then we can find the value of d from this equation. So if I make d the subject of this equation, these two will go into the denominator on the other side. So this will be 500 over 15.5 square into pi. And then this 10 will go into the numerator. So let's calculate this. 500 into 10 will be 5000 divided by 15.5 square into pi. So your value is 6.62 millimeters. So this D is in millimeters. So your question asks you to convert it to the nearest millimeter. So that means 6.62 will be rounded up to 7 millimeters. So your answer is 7 millimeter. You can also double check by substituting this value here. And then if you calculate the volume by substituting 6.62 here, you should get 500. Question number 8 is you're given P equals to this. Find P when Q equals to 2.6. So you can substitute the value of Q here. So P will become 8 minus 5 into Q is 2.6, 2.6, and then divide by 2.6 as well. So this will be 8 minus 5 into 2.6, which is minus 5, and then divided by 2.6. So this is minus 1.92. Minus 1.92 up till three significant figures. Express Q in terms of P. So you have to make Q the subject of this equation. So I will take this Q to the other side. So this will become QP equals to 8 minus 5Q. And then I'll take this 5Q to the other side as well. So QP plus 5Q will equal 8. I'll take Q common, so I'll get Q into P plus 5 equals to 8. And then Q will be 8 over P plus 5. So this will be 8 over P plus 5. That's how you will make Q the subject of the equation. So let's move on to the next part. Part B is the length of parallel sides of trapezium A are x and x minus 2. For trapezium B, the parallel sides are x and x plus 3. The heights are capital H here and small h here. The area of each trapezium is 15 centimeter square. Show that capital H is this and small h is this. So we know the area of the trapezium. We can form the equation using the area. So let's first do it for trapezium A. So for trapezium A, area will be 1 over 2 into the height. Your height is capital H, and then into the sum of parallel sides. So parallel side is x plus the other parallel side is x minus 2. And then area is given, it's 15. So I'll substitute 15 here. So this will be 1 by 2 into h into x plus x becomes 2x minus 2. And then I will make x the subject of this equation to show that it comes down to this. So if I take this to the other side, so h will be, I'll take this 2 to the other side, it will be multiplied 15 into 2, and then this 2x minus 2 as it is on this side. So I just took this to the other side. And then h will be equal to 30 divided by this 2x minus 2. And now I can take 2 common in the denominator. So this will be 30 over 2 into x minus 1. And then this 2 and this 30 will cancel out. I'll be left with 15. So capital H will equal 15 over x minus 1. So this is the same as given here in the question. And then let's do the same for trapezium B as well. Trapezium B. So your area is 1 by 2 into height is now small h into sum of parallel sides x plus 3. So area is again 15. 1 over 2 into h into now you have 2x plus 3. And then I'll take this 2 to the other side. 15 multiplied by 2 will be 30 equals to h times 2x plus 3. And then 2x plus 3 comes here in the denominator. So this will be 30 over 2x plus 3. So this is also the same as asked in the question. So now you have shown capital H is this and small h is this. Part 2 is find an expression in terms of x for the difference in height, which is capital H minus h between trapezium A and trapezium B, and show that it simplifies to this. So now you have to find this difference. So capital H minus small h. So this will be equal to capital H is 15 over x minus 1. So this will be 15 over x minus 1. And then minus small h is 30 over 2x plus 3. So now you can take the LCM. So LCM will be x minus 1 into 2x plus 3. And since I multiplied 2x plus 3 for in the denominator of this, so 15 will be multiplied by 2x plus 3. And then minus 30 will be multiplied by x minus 1. So now let's open these brackets. I will get 30x. 15 times 3 is 45. And then minus 30x. And then minus and minus plus 30. So plus 30 over x minus 1 into 2x plus 3. So this plus 30x and minus 30x will be 0. 45 plus 30 will be 75 over x minus 1 into 2x plus 3. So you have shown that the difference is this, which is given in the question. Part 3, the difference in height is 1.5 centimeter. Show that this is equals to 0. So now you have found the difference in the previous part and you're given that difference is 1.5. So this difference that you calculated in the previous part, 75 over x minus 1 into 2x plus 3 equals to 1.5. So now you have to simplify and show that this equation can come down to this equation given in the question. So first, let me open the brackets in the denominator here. So I will get 75 over 2x square, x multiplied by 3 plus 3x, this minus 1 minus 2x, and then minus 3 equals to 1.5. So let me continue here. And then I will get 75 over 3x minus 2x is x. So I will get 2x square plus x minus 3 equals to 1.5. Now I'll take this, multiply this on the other side of the equation. So I will get 75 equals to 1.5 into 2x square plus x and then minus 3. So now let's open this bracket. So 1.5 into 2 is 3. So this will be 3x square plus 1.5x, and then 1.5 into 3 is 4.5. So this will be minus 4.5. And I'll take this 75 to the other side. So this will become 3x square plus 1.5x minus 4.5, and then 75 on the other side will become minus 75 equals to 0. So 4.5, so minus 4.5 minus 75. This is minus 79.5. So this is 3x squared plus 1.5x minus 79.5 equals to 0. So here you see this is 2x squared plus x minus 53 equals to 0. So x has a coefficient of 1. So I can divide by 1.5 on both sides. So 3 divided by 1.5 will be 2x squared. So this will become 2x squared. Or let me take 1.5 common so that we can show this in the steps here as well. So this will be 2x squared plus x minus, so 79.5 divided by 1.5 is 53 equals to 0. And then I take this 1.5 to the other side. 0 divided by 1.5 is again 0. So I'm left with 2x squared plus x minus 53 equals to 0. So this here is the same as given in the question. So 2x squared plus x minus 53 equals to 0. Part B is find x, giving your answer correct to 2 decimal places. So we have to basically solve this quadratic equation that we found in the previous part, 2x squared plus x minus 53 equals to 0. So we can use the quadratic formula. So x will be minus b, which will be minus 1, plus minus square root of b square, which is 1 square, minus 4 into 2 into minus 53 over 2 times this 2. So x equals to, let's calculate this, 1 minus 4 into 2 into minus 53. So this is square root of 425. So minus 1 plus square root of 425 divided by 4, or x equals to minus 1 minus square root of 425 divided by 4. So let's take this square root. This is 20. So plus 20.615 minus 1. So minus 1 and then divide by 4. So this is 4.90 up till 3 significant figures. And let's calculate this one as well. So again, square root of 425 and then minus 1 minus the square root of 425 divided by 4. So this is minus 5.40. But if you look at what x is, x is this length of parallel side, and x is also this side of this trapezium A. So the length of a side of a trapezium cannot be a negative value, right? So this value here is not applicable. We will use this value and this will be our actual answer, 4.90. So the next question, question number 9 is ABCD represents the triangular sloping surface of a rectangular sloping surface of a triangular prism. ABEF is a horizontal rectangle, so ABEF is a horizontal rectangle. CE and DF are vertical, so these are vertical lines. And you're given this angle, and this side is 5 and this side is 2. So the first part is calculate AC. So AC is this length here. And if you look at this um triangle ADC, this angle here ADC is 90° because it's a rectangular sloping surface. So this slope here is a rectangle, so this angle is 90°. So if this angle is 90°, we have this side of the triangle side is 2, this side is 5, and AC is the hypotenuse. So AC, we can use the Pythagoras theorem. AC square will be equal to AD square plus DC square. So AC square will be 2 square plus 5 square. So AC square will be 4 plus 25 is 29. So AC is square root of 29, which is 5.39 up to 3 significant figures. 5.39, the units is meter. So this is 5.39. The next part is calculate CE. So CE is this vertical height here. And since we know that CE and DF are vertical, so this angle here will be 90° as well. So if you look at this triangle BCE, this hypotenuse BC will be 2 as well because it is part of this rectangular slope. So since this side of the rectangle is 2, this side will be 2 as well. And now we know the hypotenuse. We need to calculate this length CE, which is the perpendicular, and we know this this angle is 15 degrees. So in this triangle BEC, I can use sine of 15. So sine of angle CBE. CBE will be equal to this perpendicular, which is CE, divided by the hypotenuse, which is BC. So this will be sine of CBE is 15, CE is we need to calculate, and BC is 2. So this will give you CE equals to So let me actually write it up here. CE will be equal to 2 times sine of 15. So this will be CE sine of 15 multiplied by 2. So this is 0.518, 0.518 meters. So 0.518 up till 3 significant figures. The next part is calculate the angle FAE. So let's go back. FAE is this angle here. So now if you look at this angle DAF, since CBE is 15, this angle here is 15 degrees as well. So basically I can use triangle ADF to find this length AF. If I know this length AF, I know this length will also be 5 since this length on the top is 5 as well. So this length FE, length FE is also 5. So this length will also be known. And since the base is a rectangle, that means this is a 90-degree angle. So I can use, so in fact, FAE is this angle here up till here. So I can use this triangle. I know this side. I will calculate AF first, and then I can use this perpendicular over base. So I can use tan of FAE for this right angled triangle, which is AFE. So AFE is a right angled triangle. So let's first calculate the length AF. AF will be cosine of this 15 degrees. So for calculating AF, I'm using this triangle DAF. So let me mark that as well. So this is the triangle that I'm looking at right now. And for this, I have hypotenuse 2 and AF is unknown. So let me write this down. Cosine of angle DAF, angle DAF will equal, base is AF over hypotenuse is AD. AF over AD. So from this, cosine of DAF, angle DAF is 15 degrees. AF is unknown, AD is 2. So this will give me AF cos of 15 multiplied by 2. So 1.932. So AF will be 1.932. So now I know this length AF is 1.932. This length here is 5. I need to find this angle FAE. So I can use tan of FAE for this right angle triangle AFE, which is a right angle triangle. So tan of angle FAE will equal this FE over AF. So length FE over length AF. So this is tan of FAE will equal, FE is 5 and AF is 1.932. So this will be 5 over 1.932. So 5 divided by 1.932 and then tan inverse of this. So tan inverse of this will give me the required angle. So angle FAE will be 68.9 up till 1 decimal place. So part B1 is a triangle has sides 10 centimeter, 9 centimeter, and 6 centimeter, and angle of theta degrees as shown in the diagram. Calculate theta. So to calculate theta, we can use the cosine rule because we know the lengths of all three sides of the triangle. So since this side 10 is opposite to this theta degrees, I will use the cosine rule, which will be 10 square will equal the other two sides, which is 9 square plus 6 square minus 2 times the product of these two sides, 2 times 9 times 6 times cos of theta degrees. So theta is this. So let's calculate now value of theta from this. So this 10 square will be 100. 100 minus, so if I take this 9 square, so let me first actually calculate these. So 100 equals to, this will be 81 plus 36. The square of 9 is 81 plus 6 square is 36. So this is 117 minus 2 into 9 into 6 minus 108. So minus 108 uh, cos of theta. So if I take this 117 to the other side, I will get minus 17 equals minus 108 cos of theta. So minus and minus will cancel out. So 17 divided by 108. So I took 108 to the other side. So cos of theta will be 0.157407. So let's take the cos inverse of this. And this gives me 80.9435. So up till one decimal place, the value of theta will be 80.9 degrees. So your answer here is 80.9 degrees. Part 2 is the triangle KGH has sides of A centimeter, B and C centimeter as shown in the diagram. It is given that KGH is an obtuse angle. So obtuse angle, it means it's greater than 90 but less than 180 degrees. Complete the statement below using one of the symbols. So C square, the length of this square is A square plus B square. So since this angle here, KGH is obtuse, this is greater than C square is greater than A square plus B square. So we can show this, prove this using again the cosine rule. So if you apply the cosine rule on this triangle, similar to how we did it in the previous one, in fact exactly the same way, because we are looking at these three sides and the same angle as in this one. So if I apply the cosine rule, I get C square, like we did here, 10 square should equal the other two lengths, A square plus B square minus 2 times AB and cos of angle KGH, cos of angle KGH. And we are given that KGH is an obtuse angle. So if we look at the four quadrants, we know that in the first quadrant, all sine, cos and tan are positive. In the second quadrant, only sine is positive. In the third quadrant, only uh, tan is positive, and in the fourth quadrant you have cos, which is positive. So if KGH is an obtuse angle, that means it's greater than this 90 degree but less than 180. So it lies somewhere in this second quadrant where only sine is positive. So that means once I take the cos of KGH, I will get a negative value. So let's say, let's take any value between 90 and 1. Let's take 100 degrees. So let me show you here in the calculator. So cos of 100 will be a negative value, minus 0.173. And similarly, if you take any value between 90 and 180, the cosine value will be negative. So that means once I take the cos of this, it will come out to be negative, and this negative sign will become positive. So C square will actually become A square plus B square plus 2AB and then cos of whatever the angle KGH is. So now if you take the cos, you ignore the sign because you have already incorporated the sign. So this negative sign will make this negative sign positive. So now from this equation, you can see that C square is A square plus B square plus this value. So if you're adding something to a square plus b square to get c square, that means c square is definitely larger than a square plus b square, because you're adding this to a square plus b square to get the value of c square. So c square will be greater than a square plus b square. So let's move on to the next question. So question number 10 is 100 electric light bulbs of brand A were tested to find how long each bulb lasted. The results are summarized below. So two bulbs lasted less than 50 hours. Again, two bulbs lasted between 50 and 100 hours, and so on. So part A is complete the cumulative frequency table below. So you have time and then cumulative frequency. So you less than equal to 50, you have two bulbs. Less than equal to 100, you have these two that last between 50 and 100, and these two which last less than 50. So cumulatively less than 100, you have four bulbs. And then less than 150, you will have these four that last less than equal to 100, plus this 10 which like last between 100 and 150. So 10 plus 4 will be 14, and then less than equal to 200 will be 14 plus this 40, which will be 44, and then less than equal to 250 will be 44 plus, sorry, this will be 54 in fact. So 54 plus 30 will be 84. 84 plus 14 will be 98. So this will be your cumulative frequency table. Part B is on the grid, draw a smooth cumulative frequency curve to represent this information. Label this curve brand A. So you have hours on x-axis and cumulative frequency on the y-axis. So less than equal to 50, you have 2. So on the y-axis, uh, each small of these blocks represents a value of 2. So at 50, this will be your point. And then less than equal to 100, you have 4. So this will be this one. Less than equal to 150, you have 14. So this is 10, 12, 14. Less than equal to 200, you have 54. 54 will be this here. Less than equal to 250 is 84. So 80, 82, 84. And then less than equal to 300, you have 98, which will be this one. And less than equal to 350, you have 100. So now we can draw the smooth curve to represent these points. So this will be your cumulative frequency curve. Part A, C1 is use your graph to estimate the median. So median value will be 50th value at 50th percentile of your total frequency. So your total frequency is 100. So your 50th percentile here will be 50 over 100 into 100, which is basically 50. So now you will see what is the value when the cumulative frequency value is 50. So 50 is this one, and we have to label this brand A as well. So let's look at the value when your cumulative frequency is 50. So let's see where it intersects the curve here. So it's at this point, and if I draw a vertical line here, so this point here is, so each small block here represents a value of 5. So this is 200. So this value here will be 195. So your median value is 195 hours. Part 2 is use your graph to estimate the interquartile range. So your upper quartile will be the value at 75th percentile value. So 75th percentile value, and then your lower quartile will be your 25th percentile value. So let's find these. So your 75th percentile will be the value at 75. Since your total frequency is 100, it's pretty straightforward. Your 75th percentile will be at 75. So this is 60, 62, 64, 66, 68, 70, 72, 74, and 75 will be in the middle of this small block. So let me draw a straight line from here and see where it intersects your graph, cumulative frequency graph. So it intersects at this point. So if I draw a vertical line straight down, I end up here. So this is 250, 245, 240, 235, and this is 230. So it's between 230 and 235. So I can take the value to be around 232. So this is your 75th percentile, and then your 25th percentile will be 20, 22, 24, 25 will be in the middle of this small block. So let's see where this intersects our curve. So it's at this point in the middle here. So I'll draw a straight line down. So again, this is 150, 155, 160, 165. So it looks like around 167. So your 75th percentile value is 232 and your other value is 167. So your interquartile range will be interquartile range will equal your upper quartile 232 minus your lower quartile, which is 167. So 232 minus 167 will be 65. So your interquartile range is 65 hours. Part D is 100 brand B bulbs gave the following results. So you're given a few results, and then on the grid, draw and label the cumulative frequency curve for brand B bulbs. So for brand B, first we need to get the points from these results that are given. So your first result is 4 bulbs lasted 50 hours or less. So that means when your number of hours is 50, you have your cumulative frequency is 4 because 4 bulbs lasted 50 hours or less. It's similar to saying here you have 2 bulbs that lasted 50 hours or less for brand A. So from this, we get this point. The longest time any bulb lasted was 300 hours. So that means once you reach 300 hours, you have gone through all the 100 bulbs. So the maximum possible number of hours that a bulb lasted was 300. So that means all bulbs, all 100 of these bulbs lasted 300 hours or less. Then the median is 250 hours. So your median value is 250 and your 250 hours is the median value, so it will be the 50th percentile. So again, 50th percentile of 100 will be 50. Your upper quartile is 275 hours, so that gives you 275 hours, and your upper quartile is at 75th percentile. So 75th percentile of 100 is 75. And then the last point is your interquartile range is 75 hours. So your lower quartile, you can calculate the lower quartile through this, is upper quartile minus your interquartile range. So I'm writing is at IQR. So your upper quartile is 275 minus your interquartile range is 75. So you get 200. So that means 200 is your lower quartile, and lower quartile is at 25th percentile of 100. So you will have 25 here. So now we have these 1, 2, 3, 4, 5 points that we can use to plot this cumulative frequency curve for brand B. So let me select these and move them up so that I can plot the graph here. So, all right, let's use these points now. So your first point is 50 and 4. So 50 and 4 will be this point here. Then you have 300 and 100. So 300 and 100 is this point. Then you have 250 and 50. 250 and 50 is this point. 275 and 75. So 275 is this line. And then this is 70, 72, 74, and 75 is this. So 275 and 75. And then you have 225. 200, 20, 22, 24, 25 will be this point here. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I've plotted the 5 points, and now I can draw the curve. So this will be your curve for brand B. So let's move on to the next part. Use your graph to estimate the number of brand A bulbs that lasted 275 hours or less. So that means we have to look at your brand A graph, which is this blue line. And for 275 will be this. So we need to find the cumulative frequency value when on the x-axis your value is 275 hours, because we are looking for number of bulbs that lasted 275 hours or less. So let me draw a straight line now to see where it intersects my graph. So it's around this point here. So let's see what the value is on y-axis. Oh, sorry. Yeah, y-axis. So this is 80, this is 90, this is almost 92. So the number of brand A bulbs that lasted 275 hours or less is 92. So you looked at the value, cumulative frequency value, when number of hours was 275. So that gave you the number of bulbs that can last 275 hours or less. So your number is 92. So your answer here will be 92. Complete the statement below. Brand dash had dash more bulbs that lasted longer than 275 hours than brand dash. So now you're looking for bulbs that last longer than 275 hours. So let's first look at brand A. So bulbs lasting greater than 275 hours. So for brand A, so let me actually write it a little ahead. So for brand A, in the previous part, you calculated that 92 bulbs last 275 hours or less. So that means the remaining 8, because your total was 100, so that means the remaining 8 will last longer than 275 hours. So you have 8 bulbs of brand A that will last longer than 275 hours. And then for brand B, how many bulbs last greater than 275 hours? So let's look at the graph. So at 275, you actually have this point here. So this one here. So at 275 hours, your cumulative frequency value is 75. So if I look at 275 and if I go in this direction, I will end up here, which is 75. So you have for brand B, 75 bulbs last less than equal to 275 hours. So how many will last more than 275? More than 275 hours? The remaining 100 minus 75, which is 25. So that means 25 minus 8 is 17. So you have brand B, which had 17 more bulbs that lasted longer than 275 hours than brand A. So you're basically looking for the difference of these two values. So there's brand B has 17 more bulbs that will last more than 275 hours when compared to the bulbs in brand A. So that's how you will solve this part. Question 11 is triangle ABC has vertices these, and A dash, B dash, and C dash has these three vertices. Write down the column vector of the translation that maps triangle ABC onto triangle A dash, B dash, and C dash. So you know that for translation, if you have an object O and you add the translation vector to get the image I. So we can take any two corresponding points of the two triangles. Let's take this example, A and A dash. So A is your object whose column vector is 2, 2. So you have 2, 2, the coordinates, plus the translation vector is unknown. That's what we need to find. And your image is A dash. So here you have A dash as -4 and 4. So you get the image -4 and 4. So let me continue up here. So if I take this vector to the other side of the equation, I get t equals to this -4 and 4, and this becomes -2, 2. So this results in -4 minus 2 is -6, and 4 minus 2 is 2. So your translation that maps triangle ABC onto A dash, B dash, C dash is -6 and 2. Part B, PQRS is a parallelogram. The position vector of P relative to O is given by OP. OP, this vector is -4, 2, and this vector OQ is 4, 6. Part 1 is express PQ as a column vector. So we are looking for this vector PQ. I can find this vector PQ using the head to tail rule. I can add this vector, which is PO plus OQ. This will give me vector PQ. Now PO, we are given OP, so PO will be negative OP plus OQ. And now I will substitute the values. Negative OP will be negative -4, 2, plus OQ is 4 and 6. If I bring this minus inside, I get 4 and -2 here. And then plus 4, 6, this vector again. And 4 plus 4 is 8, and -2 plus 6 is 4. So your PQ column vector is 8 and 4. The next part is find RS. So RS is this vector in this direction. Since we are given that PQRS is a parallelogram, that means vector PQ is equal to vector SR. But we are looking to find RS, which is, so PQ is in this direction, RS is in opposite direction. So your vector RS will be equal to negative PQ. Because PQ is this, we are looking for this. So you just multiply this with the negative sign And since it's a parallelogram, your vector PQ is equal to SR. So negative PQ will be, you found PQ in the previous part actually, 8, 4 here. So this will be minus 8 and 4. So this will be minus 8 and minus 4. The next part is find the magnitude of RS. So RS magnitude will be simply minus 8 square plus minus 4 square and then whole under root. So this will be 64 plus 16 under root. 64 plus 16 will be 80 under root 80. So let's take the square root of 80. So this will be 8.94 up till 3 significant figures, 8.94. Part C is the diagram shows triangle D, an enlargement with center 5, 4 and scale factor of 2 maps triangle D onto triangle E. Draw and label triangle E. So your center of enlargement is 5, 4. So 5 is this, and then on the y-axis you have one block equals 1 point. So this will be 1, 2, 3, 4. So this is your center of enlargement. Now your scale factor is 2 and you have to map triangle D onto triangle E. So there are two ways to do this. I will describe both. You can use either of the two. You will get the same answer. The first one is using column vectors. So you take your center of enlargement as the origin and then you calculate the coordinates of all the three vertices. So let's take this point here. What is the coordinates of this point respect to this center of enlargement? So you move 2 in the positive x and 2 in the positive y. So let me actually mark these points A, B, and C. So you can write C equals to 2 and 2 column vector. Remember, I'm treating this point as the origin. So you have 2 and 2. And then to calculate C dash, which is the image of C after the enlargement, you simply multiply the column vector with your scale factor. So your scale factor is 2. So 2 multiplied by 2, 2 will give you 4, 4. Now again, this 4 and 4 are the coordinates with respect to the center of enlargement. So 4 in positive x, that means 1, 2, 3, 4, and then 4 in positive y, 1, 2, 3, 4. So this is your point 4, 4 with respect to this origin, and this will be your C dash image in triangle E. The other method is you can use your scale or a ruler and then you measure the length here. So this is approximately 4.4 centimeters. And then your scale factor is 2, right? So that means you will double the length. So if this point, which is point A, it is 4.4 centimeters from your center of enlargement, your point A dash will be double the length. So in fact, let me also mark this as O. So O is your center of enlargement and OA is 4.4 centimeter. So OA dash will be the double 8.8 centimeter. And you will measure it in the same direction as A. So A is towards this side. So you will extend it further to make OA dash double the length. If your scale factor was negative, you will go in the opposite direction of the point. So if point is on this side, you join this. So this is the line joining the point A with this center O. You will extend it on the other side. So you will make a line which is 8.8 centimeter in this direction if your scale factor was negative. But since your scale factor is positive in this case, you will draw the line in the same direction. So if this is 4.4, 8.8 is this point here. So I can actually extend this line. So let me align my ruler here. And then mark this point here. So this is your point A dash. So this is your C dash, this is your A dash, And B, since B point is also on the center of enlargement, so B will move nowhere. So B dash will be the same as B. So now you have A dash, B dash, and C dash. You can join these to get the triangle E. So let me join them using a straight line here. And this line here. So this is your triangle E. So let me just erase these coordinates. So the next part is an enlargement, and then enlargement with center 5, 4. And now your scale factor is 0.5, maps triangle D onto triangle F. Draw and label triangle F. So again, your center of enlargement is this point. So let me mark these again, A, B, and C. And your center of enlargement is also the same point as point B. So again, B dash will be the same point as the center of enlargement because point B is on the center of enlargement, so it will not move anywhere. And then again, I will use the ruler now to find C dash. So your point C here is at a distance of about 2.8 centimeters from your center of enlargement here. So now I will half that distance. So OC is about 2.8. So OC dash will be about 1.4, which is this point here. So your C dash, in fact, let me change the color for my next triangle. So your C dash is this point. And then similarly, OA is this length. I will half this length. You can use the ruler, or I can straight away see that midpoint is this one. So this is half the length of OA. So A dash will be this point. So now B dash is this, C dash is this, A dash is this, and I can join them to get triangle F. So if you want, you can draw these lines as well. In fact, let me just draw these two. They kind of overlap each other. So this is your triangle F. Oops. So I'll just erase these. So let's move on to the next part here. Let me get this ruler out of the way. Next part is triangle G has vertices these. Triangle F can be mapped onto triangle G using a single enlargement. Triangle F can also be mapped onto triangle G using a different single transformation T. Describe fully the single transformation T. So let me first draw this triangle G so that we can find out what kind of transformation do we need. So G has coordinates 5, 4. So again, this point 4, 3. So 4, 1, 2, 3 will be this point, and then 3, 5. 3 and 5 will be this point. So let me draw this triangle. So this is your triangle G. Now the question asks, triangle F can be mapped onto triangle G using an enlargement. So what other kind of transformation can also map this triangle F to this triangle G? So enlargement is already given, so we have to find a different transformation. It cannot be a translation because you can see that the orientation of this triangle F has changed. If it was a translation, it would have simply moved like right or left or up or down, and the orientation would have still remained the same. So translation is out of question. Uh, Reflection is another transformation that we can try to see if that makes sense. So for reflection, how do I find the line of reflection? My line bisector of 2 points. So let me again mark these as, so let me call this A dash, B dash, and C dash. C will be also the same. So this is A. Let me write this in green. So this point is C, this is A, and this is B. So A is mapped onto A dash, B is mapped onto B dash, and so on. So now if it was a reflection, let's see if we can find the line of reflection. So line of reflection is basically the line bisector of A and A dash. So A and A dash, the line bisector will look something like this, right? Going through the middle and making a 90-degree angle for the line A dash. And then if you take the line bisector of B dash, the line B dash, it's actually a different line bisector, something like this. So you're getting different line bisectors if you're trying to find uh, the the line of reflection. If you assume that this was a reflection and you're trying to find the line of reflection, each corresponding pair of points is giving you a different line of reflection. So that means it's not a reflection. Otherwise, if it was a reflection, you will get the same line bisectors for A dash, B dash, and C dash. So this is not a reflection. So that only leaves us with rotation. So let's see if we can show that you can map triangle F onto triangle G through rotation. So for rotation, your center is this O, this point, which is also C and C dash. So since point C is on the center, it will not move. So C dash is also the same point. That's okay. And then if you join your point A with the center O, and then you check A dash. So if you rotate this line OA 180 degrees like this, you get the line OA dash. So that's good. And then similarly, if you have this line OB, if you rotate it 180 degrees, you get this line OB dash. So that means it's a 180-degree rotation around this center. 5 4, which is the point 5 4. Point C didn't move because it was already on the center of rotation. You can see the line joining the center with point A rotated 180 degrees. So this line became this line here, OA dash. OB was rotated 180 degrees and it became OB dash. So the other transformation that maps triangle F onto triangle G is in fact a rotation. So let me write it down here. So it's a rotation of 180 degrees around, so your center, so around center, your center of rotation is this point here, which is 5 and 4 on the y-axis. So 5 and 4. And you do not need to specify that the rotation is clockwise or anti-clockwise. It doesn't matter, because if you rotate 180 degrees like this, which is anti-clockwise, or if you rotate 180 degrees like this, which is in the clockwise direction, you end up at the same position. So for 180-degree rotation, it doesn't matter if it's clockwise or anti-clockwise. So that's how you will solve this problem. So this is the end of paper 2, variant 1, for May-June 2016.